Okay, this lesson is looking at vertically opposite angles, which builds on the previous lesson looking at angles at a point. And it basically brings all the three rules that we've looked at already together. So if we just take a look at these angles here, what do we notice? So what we should notice is that we end up with 60, 120, which is interesting. But also on this other one, we go 130 and 130 repeats itself. We've got 40 and 40 and 10 and 10. So the key part of the pattern is that we should notice if I put a straight line here, or a reasonably straight line, we should notice it looks like a mirror. It's the same on both sides. And it's the same on both sides here. And it kind of makes sense because if those red lines represent 180 degrees, then it's 180 degrees on both sides of the line. So on this side, this angle and this angle, and this side, this angle and this angle. So presuming that the other line that cuts through the point goes all the way straight through and is straight as well, that represents 180 as well. So basically with those lines is that they should be supplementary with all their angles along them. And if it's the same on both sides, then we end up with that repeating pattern. So because we know that angles at a point equals 360, it makes sense that the angles on this side, or A plus B, is equal to 180. And also that C is equal to D. So it makes sense that if C and D equals 180, then C and B must equal 180 as well. So the rule is where we have vertically opposite angles, they are equal. Again, there's a GeoGebra applet. So once on this GeoGebra applet, it's the same as before. We can look at angles on a straight line. So we're quite happy that as I move this around, the green one gets bigger and the purple one gets smaller, but the whole time they stay at 180. Now, if I bring the next angle in, what we can see is as I move this one around, that the line on the opposite side of the line mirrors what's happening on the below the line. So that's why they always keep the same. And it doesn't matter if I move this line or this line, the greens are always the same. And if I add the purples in, we end up with the same value. So the key thing is remember that vertically opposite angles are equal in size. So what does that mean for working out questions? Then we can quite quickly work out that B and D in this one are equal and A and C. E and F, H and G are equal. Now this one is when it starts to get a little bit more complicated. So the key thing is to look at the point, and again they should look the same. So N and M are small acute angles. I and J, again, vertically opposite, and then K and L. So when answering questions, really simply, A is equal to 4 degrees because they're vertically opposite. Here, B and C. So first thing we need to do is B. What is B? B must be 50 degrees. And the reason why B must be 50 degrees is because it's on a straight line. So it's 180, take away 130, which is equal to 50 degrees. Now, it's really good to include your reasoning. So we can say supplementary angles. Now that I know that, I can either use the fact that I know that C is vertically, or the fact that it's supplementary with B. In this case, I'm going to say C is equal to 130 degrees, and that's because it's vertically notice how I use the angle there as a shorthand, which you're welcome to do as well. Now the thing is with this question, I could have done it either way. I could have said worked out C first and then used C and B as supplementary angles. There's no set rule or process. You just as long as you find the angle, that's fine. Right, this one's a little interesting as well. So rather than being given just a single variable, we've actually got 4. So you need a little bit of algebra to work out, and the key is to write the equation. So we know that these two angles must be vertically opposite, so they're equal. So we write that 4x is equal to 100. So the key thing is, and we can then solve that. So 4 times the number equals 100. So x must be equal to 100 divided by 4, meaning that x must be 25. So the actual angle for x is equal to 100, but x itself is equal to 25 degrees. Another way to think about it is to, if I draw the diagram, it's like this has been divided into 4 x's. Oh, I need one more there. And that's 100. So sometimes you'll see questions written like that as well. Right, I want you to have a go at this question in your book. You need to work out what U is, and then I want you to write what the reason is, V, what that is, and the reason, and then W, and then give your reason as well. So try to choose from vertically opposite angles, supplementary angles, or complementary, of course, as well, or angles at a point. Angles at point. Okay, they're the 3 main reasons. Try and work your way, see if you can present that. Pause the video, and once you've finished, restart it. Alright, I'm presuming now that you've paused the video, you've had a crack at this, you've got a reason for each one. Let's see how you got on. Okay, so these are my answers. U was 123 degrees. V was 57, as it's supplementary with V. Oh, I didn't give a reason there. I should say supplementary. Angle with 123, and W is equal to 57 as well, opposite V. So that's it. So it's another rule to add to the mix. Go back to the lesson page. There's a worksheet for you to complete.